So 6E is all about identities, and identities are just rules you need to follow. The rules are in the remember box, but the most important one, at least for the start of this exercise, is this rule here. So sine squared theta plus cos squared theta equals 1. It's a terrible theta. Okay, so that identity, it's a rule, it's always true. So if you know sine something, sine of an angle equals whatever it does, you can actually find the cos using this rule here. Okay, and I'm pretty sure that's what it first asks you to do. Okay, so if we actually have a look at question 2a, or question 2, it's got sine theta equals 0.8. Okay, and then A is to find cos theta. So we've got to try and find cos theta. So what you do is you sub that into this identity here. So you say, okay, 0.8 squared plus cos squared theta equals 1. So 0.8 squared is 0.64 plus cos squared theta equals 1. So then you're going to minus that over to the other side. So cos squared theta equals 0.36. Right? Cos theta equals the square root of 0.36, which is 0.6. So cos theta equals that. That's how easy it is. All right, relatively simple. So that's just that one identity there. They do share quite a few other identities with you on that page. Okay, the second one being, let's highlight that in red, which you can't see anyway. Sine 90 minus theta actually equals cos theta. All right. Now, if we relate that to our unit circle, you might understand why that is. So I'm going to try and relate this to the unit circle for you. How is it that this formula, 90 minus our angle, is cos theta? Okay. I like your theory. I'm going to add something else that might help you understand. Love the silence, guys. Good job. That might explain why you're being silent. All right. What's this angle here? This green angle? No, that's this angle here. What is it? How do you work it out?
You minus theta and 90.
So if you do 180 minus 90 minus theta, so it's 180 minus 90.
No.
90, and then 90 minus theta. So this angle here is 90 minus theta, isn't it? Yeah? And if this is theta here, cos of this, why is that a h there? Wow. If this is our angle we're working from, this is opposite, this is adjacent, this is hypotenuse. So sine of this angle here is this over this. Yeah? But cos of this angle here is this divided by this. Yes? So A over H. So if we now look at it from the green perspective, sine of this angle here is what? O over H. So it's this side divided by this side. Can you see how they relate to each other? Okay. This 90 minus theta is basically saying, well, the other angle in the triangle. Okay, we know that the right angle is here. We know that's 90, so that leaves us 90 degrees to work with. This angle is theta. This angle is therefore 90 subtract theta. So we start flipping which angle we're looking at. That's all that bit does, is that says this is the green angle. So sine of the green angle is cos of our original angle. Right? And then the same, so they've actually got the same identity twice there. So you've got sine of pi on 2 minus theta equals cos theta as well. Now they are actually the same identity. Why is that? Pi on 2 is 90. Okay, so anytime you see pi in an angle, try and think of it as 180. Alright, so that's just 180 divided by 2, which is 90. So those are actually the same identity. Okay, and it still relates to this triangle down here about finding which angle we're working from. Okay?
Can we do an example for that?
Yeah, which one? Okay, so let's do question 8, the multiple choice there, 8a. They've said sine 54 is equal to what? So we've got 5 options there. We've got cos 54, we've got cos 36, we've got tan 36, we've got sine 36, and we've got tan 54. Which one of those options is the correct option given our identity? Alright, that's actually not using that identity, it's using the cos version of it. Oops. So cos 90 minus theta equals sine theta. And then you've got the pi on 2 minus theta as well. Alright, so there's another identity which is exactly the same, believe it or not, as this sine identity up here. But this one is actually asking us to use this one. Sine 54 is this guy here. That's cos of 90 minus that angle. So what's cos of 90 minus 54? It's 90 minus 54.
36.
There it is right there. Okay, so it's the reversed angle and then the cos of that for this one. Alright, there is one more identity that they have given you, and this one is perhaps one that you may already know given what we've talked about, but just to refresh your memory, tan theta equals sine theta over cos theta. Right, that's what tan is. Tan is sine over cos. So if you've been given sine, okay, you can actually use the first identity we talked about to find cos, and then you can use those two answers to find tan, which is what it actually asked you to do in 2a. Sorry, in question 2. So we already did 2a, okay, and we were given, so sine theta equals 0.8. We calculated cos theta in part A to be 0.6, and then part B asks us to find tan of theta. So what do I need to do? Tan theta equals sine theta over cos theta, so it's 0.8 over 0.6, which is 1.3333 recurring. Alright, so these two identities here, this one and this one, are used for calculating the other, right? So if you're given sine, you can calculate cos, and given those two, you can then calculate tan. These identities down here, if I can get them all on the screen at once, right, are more about just using triangular rules to tell us which direction we're looking for. Make as much sense as it can. Any more examples you want me to do?
Question 11 somewhere.
11, okay. So we've got A, B and C are less than 90. Okay, so this is question 11. Yep, so they're in quadrant 1. Good. So quadrant 1. Okay, A, B and C are less than 90, which means they're in quadrant 1. Sine A is 2 over root 5. Cos B, 3 over 5. And tan C is root 11 over 5. So they've given us 3 different ratios, none of which interweave with each other. Okay, you've got C, B and A, so we can't do anything between them just yet. But part A, okay, part A asks us to find sine B. How are we going to do that? Given what we've got, which ratio, or sorry, which one up here includes b?
It's cos.
Right, it's this one here.
G sin squared theta.
Yep, so you use that first identity we talked about, the sine squared theta plus cos squared theta equals 1, and you find out sine. So you say, okay, sine squared b plus cos, let's just write b equals 1. Right? Now cos squared b is actually this squared, so it's 3 on 5 squared. So sine squared b equals 3 on 5 squared. Oh, that's a plus, equals 1. Right? 3 on 5 squared, so sine squared b plus 9 on 25 equals 1. Then we're going to subtract that over to the other side, and we end up with sine squared b equals, what did I say, 16 over 25. Right, and I'm going to take that up there so we can stay on this page. Sine b equals the square root of 16 on 25, which is 4 over 5. Okay, so that's just part A. So it's just using that first identity, sine squared theta plus cos squared theta equals 1. Rearranging that to find the one you're missing. Part B then asks you to find tan b. Okay, so our next one is to find tan b. And that's what we're trying to find. So we know that cos b equals 3 on 5. We know that sine b is 4 on 5. We just calculated that one. Given this identity here, we know that tan is sine over cos. So again, we write that out. Tan theta equals sine theta over cos theta. Get in the habit of writing down the identity you're using. So sine is 4 on 5, and that's divided by 3 on 5, which I would prefer to write like this, so that I know what I'm doing, which means flipping this one and multiplying. So it's actually 4 on 5 times 5 on 3. Cancel those two, we end up with 4 on 3. So tan b, that should all be b's actually, tan b is 4 on 3. Alright, that's the sort of things they're asking you to do. It's just tying all those identities in together. It does get a little bit harder and start using these guys as well in the later parts of that question. So cos 90 minus b, okay, we're supposed to find that. So if I have a look at question H, okay, it's asking you to find cos 90 minus b. Given what we have, cos of 90 minus b, we're supposed to be able to work that out. We can do that because we know that cos of 90 minus b, according to our rule, cos of 90 minus b is equal to sine b. So we already worked out sine b right here. So I know straight away that cos of 90 minus b must be 4 on 5 because it's the same as sine b.